Unveiling software testing. What and why? Software testing is a very important activity in making computer programs. Its main purpose is to find mistakes. These mistakes are often called bugs or defects. When we test software, we run the program. We do this with the specific intention of making it fail. If it fails, we have found a problem. This helps us understand what needs to be fixed. Testing is not just about confirming that the software works as expected. It is more about actively looking for situations where it does not work. This search for errors is fundamental to creating good software that people can rely on in their daily lives or for important business tasks, ensuring stability and correctness. The primary goal of testing, therefore, is to uncover these hidden faults. Think of it like a detective searching for clues. The clues are the errors. The detective is the tester. The software is the scene of the investigation. Without this careful investigation, software might be released with many problems. These problems could cause frustration for users. They might even cause serious issues like losing data or money. So, testing acts as a safety net. It tries to catch as many problems as possible before the software reaches the people who will use it. This proactive search ensures a higher quality product and a better user experience for everyone involved with the software application. Why do we spend so much time and effort on testing? It is because software is made by humans. And humans, naturally, make mistakes. These mistakes can happen at any stage. They can happen when we are designing the software. They can happen when we are writing the computer code. Even a small typing error can sometimes lead to a big problem in how the software behaves. Therefore, testing is a way to check our work. It helps us find these human errors. By finding them early, we can correct them more easily. This makes the final software product much more reliable and trustworthy for the end users who depend on its functionality. Imagine releasing a new banking application without proper testing. Users might find they cannot transfer money, or worse, their balances might show incorrect amounts. This would lead to a loss of trust in the bank. It could also have significant financial consequences for both the users and the bank itself. This example shows why testing is not just a technical task. It is a crucial process that protects users and businesses alike. The goal is to deliver software that works correctly, predictably, and securely. This is achieved by carefully examining every part of the software to ensure it meets the required standards and expectations of all stakeholders involved in its development and use. The critical role of testing in software development. Software testing plays a vital role throughout the entire software development lifecycle. It is not something that should only happen at the very end. Instead, testing should be integrated from the early stages. When we start thinking about what the software should do, we should also start thinking about how we will test it. This early involvement helps to clarify requirements. It also helps to identify potential problems before any code is even written. If testers are involved early, they can ask important questions. These questions can help developers build a better product from the beginning, reducing the number of issues found later in the process and thus saving valuable time. One of the biggest benefits of early testing is cost saving. Finding and fixing a bug early in the development process is much cheaper. It is cheaper than finding and fixing it after the software has been released. Think about building a house. If you find a problem with the foundations after the house is built, it is very expensive to fix. But if you find the problem while laying the foundations, it is much easier and less costly. The same principle applies to software. Early bug detection means less rework for developers. It also means less disruption to the project schedule, ensuring that deadlines are more likely to be met without compromising the quality. Testing also significantly impacts project timelines and overall quality. When bugs are found late, they can cause serious delays. Developers have to stop their current work. They have to go back and fix old problems. This can push back release dates. However, if testing is done continuously, bugs are found and fixed as they appear. This keeps the project on track. It also results in a higher quality product. A product that has been thoroughly tested at each stage is more likely to be stable. It is more likely to meet the user's needs effectively, leading to greater satisfaction and a better reputation for the development team and the company. Furthermore, rigorous testing builds confidence in the software. When a development team knows their software has been well tested, they feel more confident about releasing it. Product owners and stakeholders also gain confidence. They know that the software is less likely to fail and cause problems for users. This confidence is crucial for the success of any software product. It means the software can be launched with a greater assurance of its reliability and performance. This confidence extends to the end users, who will trust the software more if it consistently works as it should, fostering loyalty and encouraging wider adoption of the application. Exploring the levels, unit and integration testing. Software testing is often performed at different levels. The first level is usually unit testing. A unit is the smallest testable part of any software. It is often a single function, a method, or a small module of code. Unit testing involves checking if these individual small pieces work correctly on their own. Developers usually perform unit tests as they write their code. They write small test scripts. These scripts automatically check if their specific piece of code does what it is supposed to do. For example, a unit test might check if a function that adds two numbers returns the correct sum for various inputs, including normal numbers, zero, and negative numbers. The main benefit of unit testing is that it isolates problems. If a unit test fails, the developer knows exactly which small piece of code has the issue. This makes it much easier and faster to find and fix the bug. It is like checking each individual brick before building a wall. If a brick is faulty, you replace it before it becomes part of the larger structure. Unit tests also act as a safety net for developers. When they make changes to the code later, they can rerun the unit tests. If all tests pass, they can be more confident that their changes have not broken anything that was previously working correctly. After unit testing, the next level is often integration testing. Once individual units have been tested and are known to work correctly on their own, they need to be combined. These combined parts then need to be tested together. This is what integration testing does. It focuses on checking the communication and interaction between different units or modules. Sometimes units work perfectly in isolation, but when they are put together, problems can arise. For example, one module might send data in a format that another module does not understand. Integration testing helps to find these kinds of interface issues. There are different ways to do integration testing. One approach is called Big Bang, where all modules are combined at once and then tested. This can be complex if many errors are found. Another approach is incremental, like top-down or bottom-up. In top-down integration, higher-level modules are tested first, and lower-level modules are gradually added. In bottom-up, the lowest-level modules are tested and integrated first, moving upwards. The goal is always the same, to ensure that the different parts of the software work together smoothly and efficiently, transferring data and control as intended without any unexpected errors. Broadening the scope system and acceptance testing. Following integration testing, the next major level is system testing. At this stage, the entire software system, fully integrated, is tested as a whole. System testing aims to verify that the complete application meets the specified requirements. It checks if all the features work together from end to end. Testers at this stage are not just looking at individual components or their interactions. They are evaluating the overall behavior of the software. For example, in an e-commerce website, system testing would involve checking the entire user journey, from browsing products, adding to the cart, making a payment, to receiving an order confirmation. It validates the system against its functional and non-functional requirements. System testing is typically performed by a dedicated testing team. This team is often independent of the development team. This independence helps to ensure unbiased testing. The testers use the software in ways that a typical user might, but also in ways that might uncover hidden problems. They follow test plans and test cases that cover various scenarios. These scenarios include normal usage, edge cases, and even error conditions. The goal is to ensure the software is robust, reliable, and performs as expected under different conditions. It checks aspects like performance, security, and usability of the entire application before it is presented to the client or users. After system testing, the final level of testing before release is usually acceptance testing. This is also known as user acceptance testing, or UAT. The primary purpose of UAT is to determine if the software is acceptable to the end users or the client. It is not about finding small bugs, as those should ideally have been caught in earlier testing stages. Instead, UAT focuses on whether the software meets the business needs and requirements from the user's perspective. Real users, or representatives of the client, perform UAT in a realistic environment, sometimes with real data, to confirm the software is fit for its intended purpose. Acceptance testing is crucial because it provides the final validation that the software is ready for deployment. If the users accept the software, it means it works for them and solves their problems. This stage often involves users performing their typical daily tasks with the new software. Their feedback is very important. If they find that the software is difficult to use, or if it does not do what they need it to do, then changes may be required before the software goes live. Thus, UAT ensures that the developed product aligns with user expectations and business objectives, ensuring a successful launch and adoption by the target audience. Section 5. Understanding Quality Assurance or QA. Quality assurance, often shortened to QA, is a broad concept. It is about ensuring quality throughout the entire software development process. QA is not just about testing the software product itself. It is about the processes used to create the software. The main goal of QA is to prevent defects from occurring in the first place. It focuses on defining and implementing standards and procedures. These standards help the development team to build high-quality software consistently. Think of QA as the overall strategy and framework for achieving quality. It involves activities like process definition, audits, training, and selecting the right tools for the job. QA aims to build confidence that quality requirements will be met. It is a proactive approach. This means it looks ahead to stop problems before they happen. For example, QA might involve ensuring that developers follow coding standards. It might involve reviewing design documents to catch potential issues early. It could also mean setting up processes for how bugs are reported and tracked. By having strong QA processes in place, a company can improve the efficiency of its development. It can also reduce the number of defects that make their way into the final product, leading to more reliable outcomes. The objectives of QA are multifaceted. One key objective is to establish a quality management system. This system includes all the policies, procedures, and guidelines that direct how software is developed and maintained. Another objective is to continuously improve these processes. QA teams often collect data and metrics about the development process. They analyze this data to identify areas where improvements can be made. For example, if many bugs are being found in a certain part of the software, QA might investigate why. They might then suggest changes to the development or testing processes for that area. Ultimately, QA is about fostering a culture of quality within the entire organization. It is not just the responsibility of a specific QA team. Everyone involved in the software development lifecycle, from project managers to designers and developers, plays a part in ensuring quality. QA provides the guidance and support to help everyone contribute effectively. This collective responsibility helps to ensure that the software not only meets technical specifications, but also satisfies user expectations and business goals. A strong QA culture leads to better products, happier customers, and a more successful business in the long run for any software company. Section 6. QA versus testing, a tale of two disciplines. It is common for people to confuse quality assurance or QA and software testing. Sometimes the terms are even used interchangeably. However, they are distinct though related concepts. Software testing is primarily a product-oriented activity. Its main goal, as we have discussed, is to find defects in the software. Testers execute the software and look for errors. They are focused on investigating the quality of the actual software product. Testing is fundamentally a destructive process in the sense that it tries to make the software fail. This helps to identify weaknesses before users encounter them, making it a critical part of quality control. Quality assurance, on the other hand, is a process-oriented activity. QA is concerned with preventing defects. It focuses on the processes and procedures used to develop the software. QA aims to ensure that these processes are effective and are being followed correctly. The idea is that if you have good processes, you are more likely to produce a good product. So QA is proactive. It tries to stop bugs from being introduced in the first place. Testing is more reactive. It finds bugs that have already been introduced into the code by developers during the development phase. Another way to understand the difference is to think about their scope. Testing is one activity within the broader umbrella of quality assurance. QA encompasses a wider range of activities designed to ensure overall quality. These activities might include process audits, training for the development team, selection of appropriate tools, and defining development standards. Testing is a specific part of this where the actual product is evaluated. QA sets up the framework and guidelines, while testing executes specific checks against the software product based on those guidelines and requirements, ensuring the product adheres to the predefined quality standards. For example, a QA process might state that all code must be reviewed by another developer before it is integrated. This is a preventative measure. Software testing, then, would involve running tests on that integrated code to see if any bugs still exist. QA is about making sure we are doing things the right way. Testing is about making sure the thing we built works the right way. Both are absolutely essential for delivering high-quality software. They work together. Strong QA processes make testing more effective, and effective testing provides feedback that can improve QA processes. They are two sides of the same quality coin. Section 7: QA's guiding hand, ensuring reliability and satisfaction. Quality assurance plays a crucial guiding role throughout the entire software development lifecycle. Its influence begins right from the initial stages, such as requirements gathering. QA processes ensure that requirements are clear, complete, testable, and unambiguous. If requirements are poorly defined, it is almost certain that the resulting software will not meet user needs, regardless of how well it is coded or tested. QA helps establish procedures for reviewing and validating these requirements. This early involvement prevents misunderstandings and reduces the likelihood of costly changes later in the project, ensuring a solid foundation for development work. During the design and development phases, QA continues to provide its guiding hand. It ensures that established coding standards and design principles are followed. This might involve conducting regular audits or reviews of design documents and code. By enforcing these standards, QA helps to create software that is not only functional but also maintainable and scalable. Well-structured code is easier to understand, modify, and test. This contributes significantly to the long-term reliability of the software. QA's focus on process adherence helps development teams work more efficiently and consistently, reducing the introduction of defects from the outset. One of the most significant contributions of QA is towards enhancing software reliability. Reliability means the software performs its intended functions correctly and consistently over time, under specified conditions. QA achieves this by promoting rigorous testing strategies, effective bug tracking, and thorough root cause analysis of defects. When a bug is found, QA processes ensure it is not just fixed, but that steps are taken to understand why it occurred. This understanding helps to prevent similar bugs from happening in the future. This continuous improvement cycle is fundamental to building truly reliable software systems that users can depend upon without frequent failures or unexpected behavior. Ultimately, the efforts of quality assurance directly contribute to user satisfaction. When software is reliable, performs well, and meets user needs, users are happy. QA helps to ensure that the user's perspective is considered throughout the development process. This includes aspects like usability, performance, and security. By championing the user and ensuring that quality is built into the software from the start, QA helps to deliver a product that provides a positive user experience. Satisfied users are more likely to continue using the software, recommend it to others, and remain loyal customers, which is vital for the success of any software product or service provider. Section 8: Mastering the craft best practices in testing and QA. To achieve high-quality software, both testing and QA activities must follow established best practices. One of the most important principles is to test early and test often. This means integrating testing activities throughout the entire software development lifecycle, not just at the end. Finding and fixing defects early is significantly less expensive and less disruptive. Unit tests should be written as code is developed. Integration tests should be performed as modules are combined. This continuous testing approach helps to catch problems quickly, making them easier to resolve and preventing them from escalating into larger, more complex issues later on. Another crucial best practice is the automation of repetitive tests. Many tests, especially unit tests and regression tests, need to be run multiple times. Regression tests ensure that new changes have not broken existing functionality. Manually performing these tests repeatedly is time-consuming, prone to human error, and often tedious. Automating these tests frees up testers to focus on more complex, exploratory testing and other quality assurance activities. Automated tests can be run quickly and consistently, providing rapid feedback to developers. This allows for faster development cycles and more reliable software builds throughout the project. Developing clear, comprehensive, and maintainable test cases is also fundamental. A good test case should clearly state what is being tested, the steps to perform the test, the input data to use, and the expected outcome. Well-written test cases ensure that testing is thorough and covers all important aspects of the software. They also make it easier for new testers to understand and execute tests. Furthermore, test cases should be regularly reviewed and updated as the software evolves. Outdated test cases can lead to missed defects or wasted effort testing features that no longer exist or have changed significantly. For quality assurance, a key best practice is to foster a culture of continuous improvement. QA processes should not be static. They should be regularly reviewed and refined based on feedback and experience. This involves collecting metrics on defect rates, testing effectiveness, and process adherence. Analyzing these metrics can help identify bottlenecks or areas for improvement in the development and testing processes. Encouraging open communication and collaboration between developers, testers, and QA personnel is also vital. A shared commitment to quality across the entire team leads to better processes and ultimately a better software product for the end users. Section 9. The end goal: quality software and happy users. In summary, both software testing and quality assurance are indispensable components of successful software development. Software testing, with its various levels from unit testing to acceptance testing, serves the critical purpose of finding defects. It is the active process of executing the software with the intent to uncover errors, inconsistencies, or missing functionalities. By systematically challenging the software, testers ensure that it behaves as expected and can handle a wide range of inputs and conditions. This rigorous examination helps to identify and rectify problems before the software reaches the hands of the end users, significantly reducing the risk of failures in a live environment. Quality assurance, on the other hand, takes a broader, more preventative approach. It focuses on the processes and standards that guide software development. QA aims to build quality into the product from the very beginning by ensuring that best practices are followed at every stage. This includes everything from clear requirement definitions and robust design principles to disciplined coding practices and effective change management. By establishing and maintaining a strong quality management system, QA strives to prevent defects from occurring in the first place. This proactive stance makes the entire development lifecycle more efficient and predictable, contributing to overall project success. Together, testing and QA work in harmony to ensure the delivery of high-quality software. QA sets the stage for quality by defining the how-to of building good software, while testing verifies that the what, the actual software product, meets those quality standards. This combined effort leads to software that is not only functional, but also reliable, secure, maintainable, and user-friendly. When software consistently meets these attributes, it instills confidence in its users. They can depend on it to perform their tasks efficiently and without frustrating interruptions or errors, which is the hallmark of a well-engineered application. Ultimately, the primary goal of investing in robust testing and QA practices is to achieve high levels of user satisfaction and ensure business success. Software that is riddled with bugs, crashes frequently, or is difficult to use will inevitably lead to unhappy users. Dissatisfied users may abandon the software, share negative reviews, and damage the reputation of the company that produced it. Conversely, high-quality software that delivers a seamless and positive experience fosters user loyalty, encourages positive word of mouth, and contributes directly to the achievement of business objectives. Therefore, a commitment to excellence in testing and QA is not just a technical necessity, but a fundamental business imperative.